Today you're going to see another program in our series of video programs on highway maintenance. I'm Bob Kelly from the Training Division here in Central Office, and our subject for today is drainage, most especially pipe installation. Pipe installation, proper pipe installation, is one of the most important activities in drainage maintenance. We are going to look at proper methods for excavating, compacting, and filling for pipe placement. Regardless of where the water comes from, it has to go somewhere. The key to successful drainage is to direct that water where you want it to be rather than where it wants to go. Lack of such direction can cause ponding on the roadway and present a hazard to the traveling public. Improperly directed water can get onto privately owned property and cause us to have complaints. Properly directed water goes off the road into prepared ditches and drainage pipes. As with any maintenance task, the very first thing that must be done is the planning. Notification from your supervisor that you are going to be involved in pipe installation raises some very pertinent and basic questions. You must know the type of road and the limits of the right-of-way. In addition, you must also have a list of your needed equipment, have scheduled your work crew, and have given some thought to the safety requirements inherent in pipe installation. Normally, as we will see in the program, pipes are installed over half of the road first, finished, and then the other half is done. This procedure, while keeping the road open to traffic, also exposes your work crew to danger. Conduct that tailgate safety talk. Remind your people just where they are going to be in relation to the traveled way. If you're using flagmen, plan to rotate them on a regular basis. Get everyone involved in safety, and chances are no one will be involved in a safety statistic. Many of our pipe installation jobs involve either going on private property or working immediately adjacent to it. Put yourself in the shoes of the property owner. How would you feel if you looked out your kitchen window some morning and saw a crew arrive with trucks and people and begin digging up your front lawn? Exactly. Take some time the day before to go out and talk to the property owner. This is really a case where an ounce of prevention will save you an awful lot of grief. Just as with the foresight you used in going out to see the property owner, exercise that same foresight in the yard prior to going out for the job. It's so much easier to pick up the extra piece of pipe or the extra tools while you're there at the source than it is to run 20 miles back. Believe me, you can be sure of almost everything before you leave that yard. Excavating for pipe installation involves something very similar to our pothole activity, in that we ask for squared sides, a bed or base that is smooth and dry. Placing pipe is, as we will see, a combination of gentleness and intelligence. The pipe is put in gently so as not to crack it, and it is put in intelligently so that the water will enter at one end and flow out the other, which of course was the whole idea of this exercise. Backfilling pipe is once again like the pothole operation, the matter of covering over and of filling up the hole that you have created by excavation. The same rules apply. Material must be placed, compacted, and the road returned to its former state. At the conclusion of this program, your instructor will demonstrate to you methods for determining proper pipe slope and grade. Normally, pipe excavation is done over one half of the traveled way. The first thing to do is to mark off the area where you're going to be excavating. This can be done in a variety of ways, although the most common is the use of blue or construction chalk. Straight, but not geometrically perfectly straight lines are needed to give you and your crew an idea of just where you're starting and where you're going. Where the lines have been marked off, the surface is broken up with a punjar or other pointed tool. This will prevent the adjacent pavement from being broken up by the backhoe. The next thing you have to do is to excavate the old existing pipe. The easiest way to do this is with the backhoe. Once the bituminous surface has been broken, the backhoe can dig out the existing earth until it reaches the old pipe. The pipe can then be pulled out using the backhoe and set aside. The operator can give you at this point a roughly shaped, smooth trench. As you can see in the picture, the foreman is using a lock level to align the pipe on its existing grade. Almost all of our pipe replacement is on existing grade. Once you have established or reconfirmed your grade or slope line, the next thing is to ensure that you've scraped to dry earth for your bedding. Remember the similarity we talked about to potholes. Here again, we need those squared sides and a firm subbase in order for our material, in this case our pipe, to rest. Once the bed is firm, dry, with even sides, the pipe can be placed in the first half of the roadway. Prior to doing this, foremen like to lay down a thin 2 to 3 inch bed of loose material that acts as a cushion for the pipe and helps it settle against the smooth, hardened earth. Once the pipe is in place, loose material should be laid along the sides of the pipe to form a cradle. This material should not come above the halfway point on the pipe. What you want to do here is to hold the pipe firmly in place, not to lose your grade, and not to dislodge the pipe from the position that you have decided is best for it. This soil is compacted by the whacker. While the whacker or the hand tamper are labor-intensive devices, it's an awful lot less laborious than digging out that pipe 3 months later and putting it in again. To dramatize the importance of good compaction, Andy Nagy came down today from 3.0 and brought with him the district training aid. The little box represents a cross-section of the highway, and our coffee can in here is a piece of uncoated corrugated pipe. What we want to do is to show you when material is put in next to the pipe and not compacted, just what does result. Now, Andy, you use this in the classrooms actually for the foremen up in the district, right?
Yes, yes.
And does it work?
It's very convincing. I think you'll see how convincing it is.
Well, let's get convinced. Okay. What do we do first?
Well, we brought along a bag of graded down 2A to simulate the apply of force to the top of the pipe here, Bob. Okay.
Which would be the same as traffic going over the pipe.
Same as a loaded truck or an automobile.
And I just push down.
Just give that a good push there. See how it's moving here, Bob?
Ah, okay. We're starting to get voids.
Uh-huh. Look here how it's starting to work along here. The more times the pipe goes down,
the bigger the void.
The bigger the void.
And this is just the result of not compacting.
Right. This is the wrong way.
Now, what we have done here is empty the old material, the non-compacted material, out and put in a cushion, a bed, if you will, for the pipe to rest on. We've already compacted this side by using the Proctor hammer as a simulated whacker or hand tamper, whatever. Andy, can we compact this side? And I think you can see that there is a noticeable change in the level of the material. I'll hold the pipe. Okay.
Okay, Bob, here we go. Okay, now if you take a look there, Bob, you'll see that the density of the material has increased and the pipe is cradled. There are no voids, all right? That was the thing we were concerned about before when we said we did it the wrong way.
Right.
Okay.
So we would consider this a lift.
Yep, that's your first lift.
All right, now our next procedure then would be to go up how far in our second lift?
We would say not further than halfway.
The halfway point of the pipe.
That's what I would suggest, okay?
So let's do it up
this
to
little experiment here. Let's pour some stuff on there. Okay, a little on the other side here.
Alrighty. And we would smooth it out just as you would if you were putting material in a ditch. And
Simulate a little shovel or hand work there.
yeah.
All right. You want to come put a little effort on that other side there?
Okay. Now,
Okay.
once again, we're, oh my gosh.
It's really going down, isn't it? Okay. How about if I put a little effort on this side?
Okay, how are we doing?
Looks pretty tight, doesn't it? Look at the difference here.
Yeah.
So you're gaining compaction. Okay. Now what we've simulated is the second lift. Now we'll add one more lift, Bob, and
Which would take us up to where?
about 2/3 of the pipe there.
So we'd just be seeing just the top.
Just the
very
top,
portion.
and we'll compact that, and we'll let you try and push down on it like you did before. I don't think I got too much. I may have gotten a little too much.
Little shovel work. Well,
Yeah.
we can just,
I think after you get it compacted, you'll find we'll go down quite a ways.
yeah. Alrighty. Now,
Okay, I'll let you put the effort on that side again.
here we go
Got
again. Yeah.
it? Okay.
Is there a place I should be starting away from the pipe, next to the pipe, the middle, or?
I don't really think it's important where you start, Bob, just that you get an effort. Your material will be confined by the sides of your
Yes,
excavation.
that's right. Yeah. So we,
Go ahead and apply your effort. Take a look at this, Bob. Look how your side is all dense, compacted. My side's really open.
now, if we get complete compaction, we should not get any movement at all. I should not be able to bend the pipe.
Shouldn't be able to
Traffic
deform
shouldn't
it.
be able to deform it. All right.
Okay.
Let's see if we can do that.
All right, Bob, why don't you give it a try? How's it work?
Ain't moving. It ain't moving.
No moving down here around the haunches?
No voids.
All right. Now, if you're out in the field, you just go ahead and put your next lift on up to your top of the pipe, and then some material for a little cushion over top, say up to a foot over the top of the pipe. And I'd venture that a pipe placed this way wouldn't settle, wouldn't move.
In fact, the pipe that was shown in the video program, the removal, was put in the very late 1930s. So that pipe is in excess of 40 years old before it went bad.
I would say that it would not be unreasonable to expect that a pipe placed this way would last another 40.
The excavation is refilled using compacted earth, 3 to 5 inch lifts, until it approaches very close to the original subbase level. Note, subbase level and not the level of the wearing course. Then the same procedure is repeated. You now have 2 pieces of pipe in that are not, unless we've done something that I haven't mentioned, joined together. For this you will need a pipe clamp. This is merely a metal sleeve-like device that fits around the pipe in much the same manner as a collar fits on a shirt. As you can see, the collar is slipped over one piece of pipe, and the other piece of pipe is slipped onto the collar, and the whole affair is simply bolted together. One way to ensure that you have a good, tight fit on your pipe collar is to tap the collar. Tap, don't hammer. Let's take a moment and review just what it is we looked at today. We talked about the necessity for getting a good, clean excavation and likened it to the pothole procedure, that is the squared sides and the firm base. We talked about the necessity for compaction, and that was certainly dramatized by the little training aid that Andy Nagy was kind enough to provide for us and showing how the compacted material actually shifted under pressure and how material that is not compacted will give you pipe failure. Pipe compaction, pipe placement is an important highway maintenance activity. A good pipe placement will last 40 years. You should never in your career with the Department of Transportation have to do the same place twice. And you will not if you do it the right way first.